comparing two proportions, and in this section we are going to learn to compare two different population proportions by either finding the confidence interval for the difference of the two population proportions or performing a hypothesis test or significance test between two sample proportions to determine if there's a difference between the two population proportions. So with regards to the confidence interval, please note that if the confidence interval contains 0, there may be no difference between P1 and P2. Okay. For the hypothesis test or significance test, our null hypothesis will be that P1 equals P2, so no change, or we could rewrite that as P1 minus P2 equals 0. The alternative hypothesis would be that P1 does not equal P2, or that the difference, P1 minus P2, is greater than 0, or that P1 minus P2 is less than 0. The conditions for two sample problems are that there must be two different populations, and the sample from each population must be independent. Okay, so what sorts of situations might we want to do? We could be wanting to compare the proportion of left-handed people in one group to the proportion of left-handed people in another group to see if they were the same or different. And we will, of course, look at some other examples as we go through our notes. So for our notation, a reminder, population proportion is using a capital P. So if we're talking about population 1, we would have P subscript 1. And for the second population, it would be P subscript 2. The sample size is N1 for the first one and N2 for the second. And the sample proportion is P hat 1 for the first one and P hat 2 for the second. Remember to write your subscripts small and lower down than your letter. So reminder, this is a parameter, and these are statistics. And also note that P hat is the number of successes in the sample divided by the sample size. Now there are conditions, of course, that must be met before we can make any inference on P1 minus P2, and I'm sure you can guess that we are talking about RIN, random. And here both samples are SRSs from the populations of interest. Independent. The samples are independent of each other. And if we sample without replacement, we have to have the 10% condition in both samples. So sampling without replacement, we have to have the 10% condition in both samples. And finally, normal. We need to check for both that NP is greater than or equal to 10. So N1 P1 is greater than or equal to 10, and 2 P2 is greater than or equal to 10. Also, N1 times 1 minus P1 is greater than or equal to 10, and 2 times 1 minus P2 is greater than or equal to 10. So you'll recall that the easy way to check this is that there are at least 10 successes and 10 failures in each sample. All right. So how do we do the two-sample proportion inferences? So when these conditions are met, we can calculate a confidence interval, or we can do a hypothesis test. So what does this mean? Well, to do a confidence interval means in this situation means to find a range, an interval, that we are, and we'll say C% confident, contains the true difference between the population proportions. Between the population proportions. Okay, now to do either a confidence interval or hypothesis test or significance test, as we were calling it previously, we need to know our estimate or our statistic. We need to know our standard deviation of the statistic. Now, to find the standard deviation of the statistic, so first of all, we will need to know the standard deviation of the statistic. Now, I would like you to recall that when to find the standard deviation of the statistic, for a sum or difference of random variables so in other words, like proportion, we add the variances, not the standard deviations. Okay, so in other words, the variance of P1 minus P2, so the variance of the sample proportions, the variance of the difference in the sample proportions, because that's what we're wanting to test or to get the critical, the confidence interval for, is going to be the sum of the variances. So the sum of the standard deviations, sum of the variance for P1 and the variance for P2. So those are the variances of your sampling distribution of the proportions. So we're going to work through this. You will recall or check in your from our equation sheet that so variance is simply the standard deviation squared. So from our equation sheet, we will have P1 times 1 minus P1 over n, all square rooted, and then we'll be squaring it. And we can do the same thing for P2. And of course, if I square a square root, we simply get P1, 1 minus P1 over, n1 and n2 there, over n1 plus P2, 1 minus P2 over n2. That's equal to the variance of their differences. Okay, the variance of the difference. So from there, if I want to know what the standard deviation is of the difference in proportions, I would take the square root. So the square root of P1 times 1 minus P1 over n1 plus P2 times 1 minus P2 over n2. This is given on your equation sheet under two-sample, in the two-sample table. So that's what we will use for our standard deviation of the statistic. However, of course, we don't know what the true proportions are. We just have our sample proportions. And so instead of actually using the standard deviation, we will use the standard error. And so instead of the parameter P1 and the parameter P2, we will use the statistic P1 hat and the statistic P2 hat.